Okay. Sir, generally in the recognition of tokens, the methods which is used for identifying these tokens are one of these available source for identifying, the recognition of tokens is the transition diagrams. Okay. So the transition diagram, it is nothing but what? It has a collection of nodes or circles called states. Okay. Each state represents a condition that could occur during the processing of scanning the input, looking for a lexeme that matches a several patterns. Okay, so generally these transition diagrams are used for recognition of tokens, and these transition diagrams have a circles which represents the states, and states represents a condition that could occur during the process of scanning the input, looking for a lexeme that matches the several patterns. Okay, and one of the transition diagram, what it is available for the recognition of tokens, we'll call it as a finite automata. Okay, sir, generally this finite automata, it is also a transition diagram. Generally it is a graph representing the possible states. Okay, so generally these finite automata, generally these are recognizers. They simply say yes or no about each possible input string. Okay, so they say generally yes or no about each possible input string. Then generally this finite automata is coming into two flavors. One is NFA and the another one is DFA. This NFA, it is non-deterministic finite automata, and DFA is a deterministic finite automata. Okay, so we will see the detail about this in detail about this both deterministic and non-deterministic finite automata. Okay. Here NFA non-deterministic finite automata. Generally, it is consisting of a finite set of states S, then a set of input symbols epsilon, a set of input symbols epsilon. Okay, the input alphabet. Generally, this is consisting of input that we are going to provide, and epsilon it indicates a empty string. Okay, and this epsilon it cannot be a member of a set of input symbols. Then a transition function that gives for each state and for each symbol in epsilon union of this empty string a set of next states. Okay, so generally a transition function it will give you the next state that is going to occur after processing of that transition function. Then a state S0 from S. Okay, so that is nothing but that is distinguished as the start state of the NFA, that is a S0. We'll call it as start state or a initial state. Then similarly a set of states F, a subset S, that is a subset from the set of states, that is distinguished as the accepting states or a final states. Okay, so these are nothing but what? The NFA. We'll see one example of a NFA. Okay, so this NFA recognizes okay. For this particular NFA, okay, a finite set of states are example here 0, 1, 2 and 3. In this a set of input symbols that is nothing but A and B. Then each transition functions that gives for each state for each symbol in epsilon union of a set of next states. For example, this if you consider this string language regular expression A bar B close the parenthesis asterisk ABB, it will recognize us all the strings which is consisting of A and B and ending with ABB. Okay, for the first time this 0 is the start state for the A symbol, it is going to give you what? Same the initial state, and for the next B it is there in the initial state. When it encounters this star, it might be what? A, any number of A. Okay, so then for next A, right, so it is giving to give you what? This B state. Then similarly for the input of B, it is going to give the next state what? This B. Now this is going to recognize a string generally which is consisting of the alphabets A and B and ending with the strings A, B, B. Okay, so this is one example for a non-deterministic finite automata. Okay, the DFA, it is nothing but a special case of NFA where there are no moves on empty strings. Generally, this DFA it doesn't make a moves for empty strings, and for each state S and input symbol A, there is exactly one edge out of S labeled A. Okay, that is generally the difference is it is not going to contain the multiple edges like that NFA is going to have. It is going to have only one edge for each input symbol. This is the difference between the NFA and DFA. So this block diagram generally showing the interaction of the parser with the lexical analyzer, and generally it is going to show the role of the parser. As you know, the lexical analyzer, it will scan the source programs and identifies the tokens in the program. Okay, so the parser generally what it will do, it will call a get token function to this lexical analyzer, and it will identify the tokens generated by the lexical analyzer. Okay, after obtaining the tokens which has been generated by the lexical analyzer, this parser constructs a parse tree. Okay, and this parse tree, it is nothing but the intermediate representation of the tokens which has been generated by a lexical analyzer. In order to generate this parse tree, okay, this parser is going to interact with a symbol tables, and this symbol table is going to store all the symbols which has been used in the source programming language. Okay, the output of this parser, it is nothing but the parse tree, and this will be what, it is nothing but the rest of the front end, the remaining part of the compiler will take place of this, and generally the output of this process generally is nothing but the intermediate representation of the source programming language. So generally the syntax analysis, it is nothing but associated with identifying and recognizing the grammar of the programming language. Okay, like the keywords, each statement has to be terminated by the semicolon, and all that recognitions will be done by using a syntax by a parser. Okay. Three types of parsers are generally available for recognition of these grammars. Okay, the one is the universal parser. Generally, this parser uses Koch, Enger, Kasami, and earlier algorithms for the recognition of the tokens. And the two these specially used methods are top-down method and the bottom-up method. In case of this top-down method, it builds the parse tree from the top, that is from the root to the leaves. Okay, and the bottom up method, this starts from the leaves and work their way into the root. Top down and bottom up. Top down starts from the root to the leaves, and the bottom up starts from the leaves to the root. So these are generally three different types of parsers are available. Okay, the work of the parser is to get the tokens from this lexical analyzer, generally which recognizes the tokens and which will convert it into the parse tree. Okay, this syntax error, it is generally associated with the mistakes which are made with respect to the syntax of the program. Okay, the compiler, okay, the role of the compiler is expected to what? To assist the programmer in locating and tracking down the errors that inevitably creep into the programs. Okay, it is also the responsibility of the compiler to assist the programmer in locating and tracking the errors. Okay, so that might creep into the program. It is the responsibility of the compiler also. Okay, so now we'll discuss the common programming errors which are occur at different levels. Okay. Okay. The different types of errors which are occurring at the different level of programming are, one is the lexical errors, which is generally includes what? Misspelling of identifiers, keywords or operators. For example, if the if has been misspelled as a AFI, okay, so this is a lexical error. Then similarly, the syntactic errors include misplaced semicolon or extra or missing parenthesis. Generally, as we know, if you consider a C programming language, each statement has to be terminated by what? Semicolon. Okay, if you miss that, generally we will call it as the syntactic errors. And the semantic errors includes type mismatches between the operators and operands. Now say for example, if you want to perform the sum of two numbers a plus b, if you want to perform the addition of two integer numbers, okay, if one of the operator is by mistake, if you make it as either a float or character, then the mismatch will occur. Then that error will call it as a semantic errors. Then the logical errors can be anything from the incorrect reasoning on the part of the programmer. For example, if the programmer want to check whether the two alphabets are numbers are equal or not, okay, so instead of that, instead of making a equal to 1, if you make this mistake, then generally we'll call it as what? A logical error here. Okay. Or instead of comparing a is greater than b, if you make it as a lesser than b, okay, so this is nothing but the example of a logical errors. Okay, and the error strategy techniques available are, one of this is what we are discussing. The first is the panic mode recovery. In this method, on discovering the error, the parser discards input symbols one at a time. Okay, the parser goes on discarding the input symbols one at a time until one of designated set of symbol taken is found. Okay, until one set of synchronizing token is found. Okay, in this case, and these generally is synchronizing tokens. Okay, so these tokens are usually delimiters. These tokens are usually the delimiters such as a semicolon or these closing parentheses, whose role in the source program is clear and unambiguous. Okay, so these synchronizing tokens generally these are a delimiter such as semicolon, opening parenthesis, closing parenthesis, open bracket, closing bracket, etc. Okay, and the role of this is clear and unambiguous. Okay, in case of this phase level recovery strategy, here on discovering error, parser may perform a local correction on the remaining input. That is, it may replace a prefix of the remaining input by some string that allows the parser to continue. Then the examples are for this is what? Generally it might be what? A replace a comma by a semicolon or a delete a extra semicolon. These are one of the example for this a phase level recovery. Okay, here on discovering the error, the parser may perform a local correction on the remaining input. That is, it may replace a prefix of the remaining input by some string that allows the parser to continue. Then the next error recovery strategy is error productions. Okay, so generally in these error productions, generally by anticipating common errors that might be encountered, okay, by anticipating that common errors that might be get generated, we can instruct the parser to generate the possible error conditions. Okay, so this is what the error productions. Then the last one is global correction. In this global correction, it would be good that a compiler to make a few changes as possible in the processing an incorrect input string. Okay, the compiler has to be adjusted itself to make some changes in the algorithm that it is going to be used. Okay, so that will call it as a global correction. Okay, we'll stop here and we'll continue in the next class.